Hello and welcome to today's video where we're exploring the effect of wind on cruise ship stability. This video follows on from my previous two, which I'll link down in the description below. If you haven't seen them, check them out first because they do cover the basics that we'll be expanding on in this video. So what happens when the wind blows against the side of a ship? Well, I think we all know it's just going to tip it over. But why doesn't it tip all the way? Well, as before, we know the centre of gravity and centre of buoyancy will be working together as soon as your ship moves off of the upright. They'll be creating a turning lever, pushing the ship back upright against the wind. The exact force that they generated is determined by the distance between those two arrows. We call this distance GZ. Simply G is the centre of gravity, and Z is just the point on that line of the force of buoyancy that's in line with the centre of gravity. So the distance between the two just becomes GZ. Of course, the actual magnitude of the force is proportional to the weight of the ship. We know gravity will be the weight of the ship, and buoyancy will match that. If they were out of balance, the ship would either sink to the bottom or fly up into the air. So we're talking huge forces here. Large ships, we're talking 50,000 tons plus. Now the separation of these arrows, of course, is what's pushing against the wind. But when the wind force increases and the ship moves further over, those arrows will move apart. You'll have noticed the GZ has increased, which means the force that they're generating to push the ship back upright has also increased. At this point, of course, the ship would be perfectly happy. The arrows are countering that wind force. But if the wind was a little stronger or overcame those, of course the ship would tip ever further still, centre of buoyancy would start to move back, and the actual uprighting force would start to decrease. As soon as the deck edge has gone below the waterline and water starts coming in, the ship is as good as lost. The other effect, of course, when the ship is leaning over, is she'll be less affected by the wind. Just watch what happens to these arrows as they approach the side of the ship. Once she's this far over, that top arrow spills over completely, so there's less wind pushing against the sides of the ship. So actually there's less force pushing her over. So it's quite unlikely the wind would get a properly loaded ship over into this condition. How could wind capsize a ship, though? Well, it all comes back to the centre of gravity. If we raise that centre of gravity up, you'll notice that GZ arm has decreased. The distance between those two forces has decreased. So there's less force pushing the ship upright. What that means is to counter this amount of wind force, the ship needs to lean even further over. It needs that bigger GZ lever to counter the force. Remember, the amount that it's countering is simply the GZ multiplied by the weight of the ship. So it's the length of that GZ arm that's important. If she has to lean this far over to counter the small wind, of course when the big wind comes along, it will just blow her straight over to the side. The centre of buoyancy will actually slide all the way to the left as the underwater shape has changed. And once she gets this far over, gravity and buoyancy are actually working together to tip the ship further over. GZ has gone negative, as we would say. The ship would, of course, be completely lost in this position. And that brings us to the end of this video. Hopefully you found the information contained useful. If you have, a thumbs up is always appreciated. Any questions, just leave them in the comments below. And until next time, take care and goodbye.